Yo, all right, what is up, everyone? Welcome to week 79 of chill kernel hacking for fun. Yeah. Um, today, today I think I'm going to start from scratch with the kernel. Kind of restart. I think we're getting to that time. I think it feels kind of ready. So I think that's just kind of what's on my mind. For a brief bit of context, so I finished the MIT class a few months ago, and then since then I've been playing around with different topics like bootloaders and porting to Clang. And I considered those two things as prerequisites for starting over from scratch with my own operating system. And now that I kind of have a good foundation with both of those, I think I'm in a place to try starting over. So I think that's going to be the vibe for today. What's up? What's up, Patch Bite? Hello, welcome. Even though the chat widget's already working, I'm gonna put my usual test 0 thing in there anyway. What's up, Bite? Welcome. All right. Yeah, give me just a moment to kind of get my chat widgets set up. Wow, people really on time today. What's up, Useless? Yeah, thanks for tuning in. So yeah, thanks for asking. I'm good. I'm still working on it. And yeah, today is going to be kind of a good day, or I'm hopeful, because I actually think we might start over from scratch with the OS. It's August 3rd. And yeah, we're not gonna, I don't know how much progress we'll actually make. So I'm like a bit of a sore throat today, so. But yeah, so it'll be, I think I'm a little bit low energy, so I think this will be an even more kind of relaxed stream than usual. But basically, I sort of feel like it's the right time to actually start over with the OS. And like what that means is I basically don't want to use JOS anymore. So for anyone that's been following along, I've been using this operating system called JOS, J-O-S, for like this whole thing. And I did not write JOS. Like JOS is the operating system that is used in this MIT course. And so I was just doing the coursework, and I ended up getting to know the code base very well. And so then that made it kind of a natural code base just to keep using for my experiments. And that's what I've been doing, for the last like months, like what's this? This is all the network stuff. So I guess here's where we kind of started over. So since May, that's when I started doing my own stuff, like my own topics that I was interested in, and that's when we started going into these boot topics. And so I was just using JOS because I was very familiar with that. But as I kind of observed in the last streams, I think JOS is really starting to get in the way of things, of like just making progress and things that I care about trying. So that's sort of what I'm thinking here. And I think I'm in a pretty good position to start over because a lot of this groundwork has already been completed. For example, I'm at this point I'm very familiar with bootloaders, and I tried every bootloader That was like streams 69 through 75, or like me trying every single bootloader. And I feel pretty comfortable with that, and that code is kind of done. So I could just reuse that code. And then all this stuff with the tool chain and using Clang. I also, yeah, I'm just going to reuse that work. And so in a certain sense, starting from scratch actually began at week 69, 10 weeks ago, but just in a very slow kind of way. So Byte, you started taking web dev, but you don't want that. You don't know what you want, cybersecurity. How can I make a choice? Well, starting with what you don't want is a good start. I mean, I would say just try some things out. If you think cybersecurity might be interesting, just like find some ways to try it out. Spend 2 weeks learning about cybersecurity. Do some hacking challenges. Do some capture the flag stuff. I mean, two weeks is not that much time, but yeah. I don't know. Maybe don't overthink it. But just try some different things out and just follow your intuition. Follow your excitement and what things seem exciting to you. It's probably my best advice. Okay, so as a concrete plan for today, what I want to do, number one, wrap up the JOS branch, merge it, review history, merge it back to the dev branch. And two, I don't know, kind of like assess, plan what starting from scratch might look like. Because I already have some concrete ideas about, like, it's going to be CMake based. We're probably going to use Limine, but with multi-boot 2. I'm probably going to keep it at 32-bit x86, and 64-bit can come later, probably. And I want to be using Clang and LLVM. And so the good news is I'm hoping kind of a lot of this is already done, because I already actually have my secret CMake JOS branch. So I in my own time have ported JOS to CMake, and I can show you that later. And so that hopefully that will make things a bit easier. Clang LVM and then CC runtime. So this is kind of a basic setup. Quickly, the reason for using Limine is mostly, the main reason, I guess, is that Limine makes it easier to use EFI if I would like to. And I plan, so that's a good point, I don't plan on using EFI, I plan on using BIOS, probably. Because it's just a little bit easier, because QEMU comes with a BIOS built into it. But with EFI, you need to pass a separate EFI firmware file, and it's just a little bit annoying. So, yeah, I mean, yeah, CTFs are not for everyone. Personally, I'm actually not a super big fan of them either. I don't have that much experience. I can't really talk about it that much. I did a bunch of them like 10 years ago. Yeah, I think practical. There's like a Venn diagram, and there are a bunch of things that you learn with CTFs that are not necessarily that practical. Yeah, Byte. Yeah, I mean, yeah, just pick a project and try. Here's Savant syndrome. I'm actually not familiar with what Savant syndrome is. Okay, but this is sort of rough. So I think I will begin. Start to just get into things over here. Yeah. So let's begin with looking at, maybe clean, maybe, wait, where's my terminal? Okay. Just gonna clean up a few things here. Okay. So this is just deleting a bunch of cruft that is not really relevant to us anymore. So I'm just going to remove GCC toolchain cruft. Okay, so basically the branch starts here. This is where the dev branch ends. Okay. So this is a bit of grub. And actually, do we still have grub files lying around? We do, okay. I will keep support for both of them, both grub and Limine. So basic grub, and then basic command line args. So I will I'll squash these two commits together, and I'll rename this initial grub support. Will I ever get into hypervisors? Maybe. Yeah, maybe. I don't know much about hypervisors, and I'd like to know more about hypervisors, so I would say that's definitely on the table, yeah. Okay, so then this commit is a small proof of concept around using add support for multi-boot v1 CLI args. Build grub ISO automatically. So I think this actually can just go into the first commit. It's all squashes in there together. Basic multi-boot v2 and basic Limine. I pray not. What's wrong with hypervisors? Also, what's up, Tech Leaf? Thank you for the message. I appreciate that a lot. Yeah. Yeah, I don't really expect to have anybody to watch all these videos. It's just so much content. It would be nice if I had more time. I could make some more edited content, but I don't exactly have the time for that at the moment. Okay, so what's this temp commit about? This is disabling a bunch of stuff and enabling ISO booting. I actually will switch to fork. It's a little bit easier to see. So yeah, we stop booting via the kernel image file, which is from kind of the old way of doing that. Okay, Patchbite sounds like you know quite a bit about hypervisors. Not standardized. Okay. Yeah, okay, I'm convinced. Yeah, I'm never going to learn about hypervisors. That sounds awful. Okay, so here basically the idea was to disable simplify things in the setup. So no more network device, no more SMP, and just switch the boot device. So I'm just curious. Come back at basic multi-boot v2 support. So now we are using multi-boot v2. And apparently I don't exactly remember the reason for this change. I know there were some crashes. Okay, but I can rename. Disable early panic. So the question is, who added the early panic? Might have been here. So curious. Okay, so what if I just do look at this whole diff? What do the make file changes look like? Okay. So all that stuff kind of stuck around. Yeah, so ideally we don't want these hunks. We just want this basically. I will just do a small test. I'm curious if oh shit. Let's go down here. I'm curious if these cause problems. Okay, doesn't seem like it so far. How do you do this again? CPUs. Oh, So the networking stuff seems to be working. And CPU 1, 2, 3 starting. CPU 0, 1, 2, 3. Okay, so actually this seems good. So what I'm going to do, I'm going to actually I'm going to just amend this right into this temp commit and then just make those lines disappear. And just for posterity, I will keep around this line, even though we're not doing things this way anymore. It's just nice to see how that used to be done in case we ever want to go back. So why is it? Okay. So this actually gets fixed up to this commit also. So now we're adding basic multi-boot v2 support. And then this is like a tiny little thing that can also go in the first commit. And then now we're on to the Limine commit. And what does this involve? Oh, stash. Okay. Okay, so I weirdly have this thing that points to this other directory. That's okay. I have the config file. And then we just have all this build system work. And then here's where we remove grub support. Just gotta make sure also timeout timer. I'm just gonna take a quick 20 seconds. Be right back. Okay. I'm fine with all this stuff. Fine with all this. So this is no longer whip. This is port to basic Limine setup. I don't know. Disable early panic. Now we're getting into all this toolchain stuff. So first off, we just use Clang just for the compiler. I might squash some of these together. Oh, this is CC runtime. Okay. Wait a sec. Sub module. I did not want to add a sub module. Wait a sec. Whoa. Oh, yeah, okay, I think I accidentally added a submodule. So then we just have a bunch of these random changes to make the Clang thing work. Okay, then we have this bug fix, and that can actually come early. So just to zoom out 1 second. So what you're watching me do is I did a bunch of this work over the last few weeks and months, and now I'm just kind of going through the Git history and kind of cleaning it up, consolidating things. I also find that helps me understand the changes better. So this is a bug fix that came out of the work to use Clang, but it's not related to Clang. So I'm actually just going to move this commit down before any of the Clang stuff. Unless it conflicts, although I don't expect that it will. So I'm just going to try. Okay. And I'm going to reword this. Okay. Prevent use of SIMD. That's also technically a bug fix. Oh, and did that conflict? Okay, I'm not really... okay, yeah, I'm not really that interested in resolving merge conflicts in the build files. So what's this about? So that's interesting. Okay, so this just adds... Weirdly, CC runtime got added here somehow. Accidentally, I think. So I'm going to undo that. I wonder if I can do that in LazyGit. I can move this into a new commit after. No. I guess not. I think I cannot use a custom patch, so I need to rebase. Okay, so now I will probably do a soft reset. No. Okay. So now I can unstage this and so now this is keep using GCC's libgcc. Right here. And then this is different. So now let's take a look at third-party CC runtime. And yeah, it's its own thing here. Versions. I don't have the versions. Okay, so what I don't want to have submodules. So I'm just going to delete the Git folder. And then that just makes things simpler. So now it's vendor in CC runtime. Okay. And I will continue the rebase. Okay, so now we're back here. So so technically these two commits can be squashed together, I think. I'm just going to do that. Can I squash? Yeah, I'll squash to keep the commit message, then I'll just rewrite the commit message. Instead of GCC, but keep using GCC's libgcc. Later we will port. Ideally, we'd use libclang RT for i386, but it's not easy to get one of those. I don't want to build it from source, so we'll instead use CC runtime. Later commit. Okay. Quick question for the chat. How's the volume today, by the way? I've been getting some reports that my videos are kind of quiet, so I'm just curious if anyone is watching and feels like telling me about that. Would be helpful. Thanks. Okay, so now we have a commit that's like use Clang instead of GCC. I mean, yeah, we could even make two branches. I mean, these are two separate streams of work. First, it was this bootloader stuff. Then it was all this Clang stuff. So if I wanted to I could, can I make a new branch here? Yeah, boot, no, boot experiments. But I don't want to, I also might just be complicating my life for no reason. But it's not that bad. So there's the boot branch, and then we're on the Clang branch. All right, nice. Thank you, Chai Kung Fu. Appreciate the comment. Also, shout out to anyone on Twitch right now. Appreciate you joining from Twitch. I'm trying out YouTube and Twitch. I'm a bit new on Twitch. So shout out. Yeah. Okay, so we have this bug fix that's sort of unrelated. That just comes first. And I don't know. Let's just make sure things still work. Always good to just, one mistake I've made in the past is just by not testing things while I go through and change and clean up the Git history, and sometimes that breaks things. But the system booted just fine. Okay, so now we got the fix. Use Clang. But keep libgcc. Okay, now we're going to vendor in cc runtime, but actually this is kind of different. Like, this commit is all about just a bunch of other miscellaneous changes to make things work with Clang. We'll just move that down. This is also a fix. And so then these two things come together. So then this is add cc runtime, right? And then we have this commit that adds the vendors in the files. And then we also just have this private versions.md that I'm just kind of recording to help keep track of what version, like what commits of things, because I'm not using sub modules. Okay, so now we have some other stuff. We have the freestanding C headers, which is a dependency of C runtime. So I guess runtime depends on this. Otherwise, we don't really have legit valid C headers for it. Okay, so now we're adding it into the build system, but we're not actually using it. We're just enabling cc runtime to be built. No one is linking against this, but it's just, and so actually this commit can even, I mean, freestanding C headers can maybe go first. Oh shit, conflict, okay. Again, not really that motivated. Why would there be conflicts? Oh, with the versions, that's the only possible conflict I think that could happen. So in that case, I am fine with view conflicts. It's just versions. So let's just, can we resolve that quickly? Okay, I don't understand this, and I'm not feeling motivated enough to figure that out. So, I mean, technically this could all be squashed into the same commit. CC run, whatever, I'll just keep it separate. So it's these three things. And then, so here in this commit now, we actually use CC runtime. And the key diff here is we no longer use libgcc at all. And then this is just a rename commit. And then now we're kind of getting into some other, the rest of the tool chain. What's up, I'm Vasi. Been trying to get better at testing recently, sick of making similar mistakes and not catching them. Yep. Yep, that's a, yeah, me too. All right. We're getting there. We're almost done. So now it's just kind of these three things. So fix tool chains, and this is like a random thing we need to do. Use full LLVM toolchain. Add assert to elf loader. This is also a bit of a random thing. I'm going to move this all the way down here. And there's a group of like random fixes that are not directly related to this work, but were uncovered due to this work. This commit is sort of pre-processed. I think I already cleaned, except for the user, damn, that user LD white space. Not great. Although I don't know if that's just Git. It didn't actually show white space. Okay, I also write into the user settings. Okay, I don't understand that. Okay, whatever. And then this is just, so these are, I mean, can this be broken down? No, I think it's make frag. So this was needed for obj copy. Okay, I'm just going to squash this here. You know, I'm just gonna, all right, I am satisfied with this. So what I'll do now is my dev branch is up to date. I will merge in the boot experiments branch. How do I do this? Merge. So I want to use fast forward. Let me just check my git config real quick. Oops. All right, let's just, I'm just gonna try this. So capital M, regular merge. Okay, I think that I did not do a fast forward. Lazy git merge fast forward. Or wait, no, I want shit, I did the opposite of what I don't want fast forwards. I was curious, can I undo? It does, okay. So let me try that one more time. Fast forward equals false. So now I'm gonna come in here and capital M and regular merge. It's still fast forwarded, so okay. Anyway, not really that important. So next up is clang. Wait a sec, I'm confused now. Why? All right, this is a little bit dumb. I'm just going to maybe do it by the command line. If I check out here. Okay. People were talking about this. I'm just gonna regular. Oh wait, merge dev into. Okay, that's like the exact. Okay, check out to dev and then merge boot experiments, regular merge. I see. So there we. Okay, now it did our no fast forward. So I think that is kind of nice. And then I'll do the same for clang and let's see what happens there. So now look at this. Oh, wait a sec. Okay, boot experiments. No, I think this is what I want. Yeah. Now we have these nice branches. They get merged in, and then the merge commit, you can see all the changes in the branch. And I will push. All right. Cool. Okay, so now that's kind of nice. Just one last check that we're still running. Seems good. Okay. Oh, did something crash? Lazy Git panics. Okay. So that was part one. Where's the pen tool? Pen? Okay. Now let's get into the good stuff. So currently, I have my JOS repo, which has like this stuff and this stuff, but it does not use CMake. And then I have this other JOS branch that is CMake, but doesn't use this stuff. And so I'm just sort of thinking about how to proceed here. I think what I'll do is I'll just have both of them in two separate repos checked out so I can reference both of them. And then I might start a third repo from scratch. Alternatively, I could just like work within the context of JOS and just like get rid of a lot of stuff, but I'm not sure I love that idea. What's up, Behind? Yeah, I think, I don't know, just starting from plain files sounds a little bit nicer. Yeah, what's up, Ismail? Yes, a little bit sick. Out kind of late last night and did a lot of talking. Have a bit of a sore throat. But it's all good. I don't know. Yeah, I think that's what I will do. So let me go to JOS 2. Actually, wait a sec. So my my CMake branch is here. Thank you, appreciate that. Why does it say work tree? Do I have a work tree? JOS WT2. I think I was playing around with work trees. CMake prod. Okay, so here is here's my CMake branch, and this is not something I've shown on stream before, although I made a YouTube video about it, but I've never talked about it on stream, I think. But this is my port of JOS to use the CMake build system, and it starts here. So let's just see if it works. It's been a while since I did this in April. All right, so yeah, let's do some CMake. I'll link you to a couple of things. So JOS is the OS used in this course, and there's also a bit of more details here on the welcome page. Yeah. CMake definitely has a lot of nice things to it. The downside of CMake is that it is like you are distanced from the actual command lines that are running a little bit, and so it's a little bit more difficult to have a lot of fine-grained control over exactly what command lines are being generated and run for the compiler and linker and stuff like this. And sometimes this matters, and so that can be a little bit annoying. With makefiles, you just you can control that very easily. But anyway, okay, let's check it out. So here's how the JOS thing works. So if so I have a build directory, so I'll make B, I'll go cd, and then I will just do CMake --, and then time to build, and I will do make J16 or something like that, and it build the OS. And how do I run it? Where's JOS WT2 Peacock? I want a new color. Okay, kind of like these weird colors. Actually, that's kind of an ugly color. All right, we'll go with this one. So now, so the GNU Makefile is still around, but I also added equivalents to these here. So build Kimu. Shit, I forget. So this is still going to use the old build system with objdr. Okay, I'm just going to ask AI, I think. Unless someone knows the answer. How do you, wait, how do you, yeah, this is a dumb question. How do I run these custom targets, e.g. to run Kimu? I'm just not remembering the command line. Oh, okay. Wait, what? Copy? D. Or did I? Oh man, this is kind of annoying. But I do want to get this working. I wish I had some notes or something. How, like, did I take any notes about how I did this? Or wait, or make key. Yeah, does this work? No. So what's up with the D? N verbose. Make Kimu. D, wait, yeah, so no, there's something very, something dash D Kimu log, so Kimu opt. Okay, so here I think we are running into a weird CMake thing. If I just get rid of this. Now, wait, so for some reason, can I jump to where is Kimu just not defined? Okay, I'm just gonna try one thing. I'm gonna delete this. I'm going to go to make CMake dev. This one. Make dev 2. I'm gonna try this one, CMake 2. Okay, this one is like a little bit not working. This one did work. Same issue. Sorry, oh, okay. Let's make dev. Okay. Yeah, so this is kind of screwed up. I think the closest thing I have to working is CMake prod. And this is, again, probably something pretty simple and stupid, but for some reason, Kimu... And it's just, it seems like there's no path to Kimu. Like, if I search for capital Kimu, toolchain.cmake. Does this exist? Yes, I think so. What's up, Beach Whale? Yeah, it's going great. Yeah, oh man, I think I forgot to update the YouTube title. It's week 79. Yeah, it's going great. Finished the OS course a couple months ago. Tried every bootloader, ported to Clang, and now I'm kind of starting over. I'm trying to, yeah, like use that Clang work, use the bootloader work, and create a foundation for a new OS for myself. And if I could only figure out what is going on here. Toolchain? Oh, Toolchain needs to be before DevTools. So that's, I think that is what was going on. And that is perhaps another frustrating thing about CMake. Like, if Kimu was undefined, why, like, there was no error about that. It's the most consistent stream on YouTube. Wait, let me, yeah, okay. Bam. All right, check this out. We're working. So that was just the issue. Like, dev, yeah, toolchain needs to come. So when in this commit, yeah, I need to, yeah, stage this commit. So yeah. In week 1, I had very little experience with like what is known as OS development in terms of like the OS dev wiki and stuff like this. But I did have a lot of general experience with programming, with C, assembly, and C++, and with build systems, debugging, stuff like this. And also I had a good amount of experience with operating systems concepts. And I also had done a bit of, like, I have like a blog, and even before I started week 1, I wrote some blog posts about some Linux kernel stuff. And so in particular, I have these 2 blog posts that I wrote that explore some like internals of the Linux kernel, in particular virtual memory. Yeah, parts of the virtual memory subsystem. So I had that kind of experience coming into it, but I'd never actually really written like kernel code, really, or not really like a significant amount of like core kernel code per se. So so I definitely had a lot to learn. Definitely have learned a lot over the past 79 weeks. Jeez. But check it out. So so CMake, the CMake branch is working and running, and that's great. And I just needed one little fix apparently to make that work. What's this temp thing? Create start fs. That's a little bit weird. Wait, let me. Who? Okay, whatever. I'm not too concerned about this. Okay. So yeah. Yeah, Ismail knows the real lore actually, because yeah, I started with XV6 for about 13 weeks and then didn't really do anything. And then I switched to JOS after that point. So that is like the real hardcore lore. And if I would not recommend watching the first 13 weeks personally. I think the JOS part is where things actually start to get much more interesting. Okay, so what do I do with this commit? Honestly, it doesn't really matter. Okay, so here in my working tree place, I have CMake version, and the other one I have like in this other place. In the normal JOS repo, I have our dev version, and I'm just wondering about the approach here, but we'll take a 20-second break, be right back. So I could technically start with bare raw files. And then I guess I would just have a goal of getting Limine set up. With CMake. But I'm wondering if that would actually be easier to do in the existing CMake setup. I sort of suspect that it might be. So I'm going to give that a try. So what I'm going to do is we're going to work in the CMake repo, or the CMake branch. And I guess we're going to try to add support for Limine to the CMake branch. And we're going to see how that goes. And we'll see how much progress we can make in about 1 hour. And in order to do this, it will be very useful to be able to reference what happened in the for Limine support in the dev branch. Yeah, I'm trying to figure that out, Ismail. My general intention is that it's like, I think it is time to kind of start over with my own OS. I think I'm kind of ready for that. and I'm just debating on the actual best way to do that, because I have all these things that I want for the OS in terms of, I mean, it's like these things are just all the things I've been working on for the last like couple months. So hopefully it should be very straightforward to do this. Yeah, so I'm just debating on the exact best approach to eventually reach kind of like this goal. And I think, like, I just sort of have the feeling that sticking within JAWS for a little bit longer will just be a better approach, rather than just starting from like blank files. So let's give that a try. What's up, Kadar Codes? Nice to see you. Okay, so we are looking at the dev branch. And in particular, we're interested in this commit port. And also just a quick note. So earlier in the stream, I was taking time to like clean up my Git history and blah, 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 blah. And I think here's a bit where it's paying off, because I can very clearly see the changes that went into doing certain things. And I can just very, very clearly see what was required to add Limine support, for example, because I post-processed the history and cleaned it up. And all I needed to do was apparently mostly just this. But this builds on the existing grub work that happened over here. But even the fact that I can like just easily find out what happened where is pretty useful. And so, okay, so basically we're going to do some CMake development today. That's what we're going to do. That's kind of cool. I think this is the first time we're doing CMake on stream. So what's up, Bolu? It's this like lo-fi hip hop video that I just use every single time. Let me see if I can find it. It's like this no copyright. I'm still deciding about the GitHub and how public I'm going to make this. Yeah, not quite sure about that yet. What's up, NSG? Yeah, kind of. A bit indirectly. So, yeah, the general idea is to start from scratch. But concretely, like, I think, like, what I want to do is, I'm working with my CMake branch of the OS, and I want to add Limine support for that just to see how that looks in CMake. And then, but then basically when it's time to actually make the actual from scratch OS, I'm hoping that it's just literally just copying and pasting a bunch of stuff that I've just already done, like with the Clang support, with the Limine support, with the all that stuff. Because I'm hoping to kind of just like do that work early right now, and then just not have all the hard parts be already done. And so this is sort of like the outstanding parts are just kind of like Clang or Limine within CMake and the Clang and LLVM stuff in CMake. And I think I'm just going to do that within JAWS. So first, so let's just take a look. So difference with yeah, yep. All right, so difference with, so okay, so now basically now we're in the CMake branch, and that one is sort of like back in time. So that one is still like it didn't get any of the nice stuff we did. It doesn't have Clang, doesn't have LLVM, doesn't have Limine, doesn't have like any of that stuff. And so we're kind of re-implementing these makefile changes in CMake. And the first kind of thing is that, okay, we're not going to be making a kernel image file anymore. We're making a os.iso file. So that, and to do that, you run these commands. And so we're going to be using some CMake custom targets, I think they're called. So let's just, I also kind of need to remember how this works. NSG, out of curiosity, do you, like, what build system do you use? Okay. But anyway, so here is where we have some CMake that is producing the kernel.image file. And makefile and Jinx for user space. Okay, so you're just using makefiles. That's pretty impressive. And this is sort of a lot of text here, but the main thing it is just doing is concatenating two files. It's concatenating this boot image file, and it's concatenating the kernel elf into one single file. And then it's like creating a symlink just for convenience. And so the build directory looks like this. It maybe it's easier to see here. So we have these directories, subdirectories for all the different like kind of subfolders in the OS, and then there's just some top level symlinks to some of these final build outputs. So what I'm going to do is I'm going to kind of duplicate this. And instead of kernel image, call this kernel ISO. So I'm just re-implementing the work that I did in the main JOS branch. And so, for example, like the name os.iso is probably not a very good name, but right now is not the time to change that. So I'm gonna call this ISO, kernel ISO, and now it's time to add our custom commands for running things. And hopefully this should be pretty easy. But so for example, immediately, one of the really nice things that I no longer have to do is add all these make-dir-p's everywhere in like every single build rule, because CMake handles all these low-level details about the directories for you. But with the old make build system, it was just like everything needed to be very careful at all times about what directories existed or did not exist or whatever. So that was kind of annoying. Okay, so what do we actually do here? We so now it's time to craft the ISO dir, right? And so maybe I kind of was speaking BS. So we need to craft this ISO dir somewhere. And we formally just chose a random location in the build directory to do this. And I guess we can kind of do a similar thing. Okay, so yeah, so maybe we actually do need the make dir. But with make dir, we place a bunch of files in there and then run a command line. But in practice, it's going to be, we're going to use a bit of this Limine stuff. And we're going to, we'll need to depend on, so we're depending on the kernel binary, but also the Limine conf file. So that's all kind of different. And this I might use some AI here to help me. This is like relatively uninteresting work that I'm not, so we need to do depend on Limine files. So for example, this is wrong. We're not depending on boot image. Need to dep on Limine conf instead. How do I do this in CMake? Can I put up, like, the simplest thing is like putting up file path here, but that's not really the best way to do that, I think. I think there will be some notion of like a target for these Limine files. This is VS Code, but I have Copilot. Okay. So I'll just start simple, which I guess is make, like, I guess we do need to do this. So as a baby step, let's try that. Git GUI, yeah, that's a lazy Git. Lazy Git, yeah. Yeah, super good Git GUI. I'm a huge fan. Okay, so at a minimum, this is what we're gonna do. And maybe we can just even, this one. Oh, this is fork. Right, yeah, I forgot. I'm switching back between these. So this is fork, and this is just like an actual nice GUI. So yeah, but it's Mac only, I think. So I'm going to blast away this whole thing. I'm going to generate the project. Can I? 14. So okay, try that one more time. And now I can just try to, for example, make kernel ISO. So now I'm just trying to trigger this workflow. Trademark workflow. Yeah. What's up, Sirius Black? What's up? So let's just run this. So running that builds the kernel, and okay, this is incredibly noisy output. Okay. Okay, so what happened is it tried to create make-dir-patch /isodir, which was, it tried to like write to the root of my system because isodir is not a thing. And so we're going to replace that with what like CMake. It's not okay. I think I need some of my CMake docs. Here's the part where I don't have CMake doc. Let me get the CMake applied. CMake binary dir, yeah. So this is just the top level, and I think that's what I want. So we're gonna do all right, nice and easy. Just trying to make a directory. So I'm just gonna run this one more time, and it's not gonna, or it nothing. Its output was kind of noisy, but so then it ran this command, and we should like now we have an isodir. So it's kind of nice. And just has this thing. So that is a tiny little baby step. Okay. Next. So I guess actually this dependency is a little bit optional. Strictly the best version of this build system will actually have a dependency on this file, and so it will be able to rebuild the ISO in case we change the limine.conf. But strictly speaking, that's not like completely necessary. Okay, so time to actually add the limine.conf, and I'm just going to dir limine and touch limine.conf, which is what this thing is called. And then I'm just going to copy and paste this whole thing. Yeah, and so like this is the part where like all that previous work to like learn about how Limine works is kind of paying off, and I'm hoping a lot of this work is just copy and pasting like existing stuff that I have gotten to work in the past. So now we have yeah, so now we have this thing, and we need to copy it in. I was kind of wondering if I could even maybe have AI do like a lot of this for me, but 20-second break, be right back. Okay. Again, very similar thing. We're going to take this and this, and that become this. And it's like a little bit sketchy because we're kind of like reaching. Actually, no, we can, now that we're in CMake world, we actually can benefit from variables like CMake source dir. These 20-second breaks are wild. Yes, sir. So now, now that we are using CMake, we actually have some nice things like CMake source dir, which lets us reference files. Okay, so then I'm gonna get this and just copy it into this path. All right. Okay, next up is this thing. We need to, yeah, okay, this is a little bit awkward. We need to copy in all of these things. What's the worst but easiest way to do this? Yeah, we just need to, I mean, it's probably just setting a variable called Limine dir somewhere around here, and I don't know, somewhere just add a git submodule path to the Limine binary in the source folder. Yeah, we don't give some, so not quite sure I understand the, yeah, I don't really want to use submodules if I can avoid that, but I think I understand what you're saying. So add a submodule to that special Limine branch with all those binaries. Yeah, I think I'm going to try to see how long I can go without adding submodules. And so for the moment, I'm just going to kind of hack it like this. Kind of a messy direct port sort of deal. Yeah, this is nice and loud and visible, so we'll want to get rid of it later. So now, curious. Yep, it's an option as well. Yeah, serious. I don't mean to ignore you, but maybe I can just point you at my little resources list. And I don't know, you just gotta like find something that's interesting to you, and then I think that's like then it'll be easy from there. And some things you could try are some security stuff at pwn.college, or just build some projects that you find interesting. Okay, so now we're in the right place. So now let's run it again. So this is looking good. Yeah, again, not really the most sophisticated work that I'm doing today, but it's honest work. And then we have this command. And we have this XOR ISO thing that you need. Okay, and okay, so this should output it into the root just directly. Which is probably fine for right now. All right, I'm going to not do verbose and just see what that looks like. Dang. Okay, so now apparently how to do multi-line lines in CMake. Oh, whoa. Look at that. Wow. Since we're in CMake world, we don't even need to do all this backslash stuff. That's funny. All right, check that out. So it worked. We have our os.iso. And our build is a bit verbose because I'm passing -v in places I don't need it. But also one thing that is a little bit unfortunate about the current situation is that it is rerunning it all the time, even if nothing changes. Which is kind of unfortunate. Current binary dir, so I think this is the problem. So I think if you look in the kern, or maybe not. Oh, I think the problem is that okay, no, I know the problem. So we need to be using current binary dir here, and then this symlink thing like we did before. And we symlink that into CMake binary dir os.iso. Man, more builds. I feel like half of my streams are just build system work, and I don't know how I feel about that. Okay, make, what was the command? Let's just make kernel.iso. Let's see how that works. So that worked, and just out of curiosity, so what do things look like? So now we have os.iso, which points into the current directory, which is where this thing actually lives. And then out of curiosity, if I run this again, hopefully it doesn't rebuild it. Check that out. Now that is a nice, like, production quality build system, which only is building things if we need to. So, yep, that feels good. Win on the build system. So what I'm kind of, I feel like something's missing. Wait. I feel like something is missing. Don't we need to copy the kernel? Okay, yeah. So this, yeah, okay. I missed this line because it wasn't in this Limine diff, but of course we need to copy the kernel. And I think this is also another opportunity for CMake to shine a little bit, because okay. Actually, okay. So now So instead of hard coding this path in the build tree, we can actually, or actually maybe we still do that. Kernel elf. So apparently this is how I was doing it previously. Kernel goes into the boot. Okay, so okay, I don't know. It's not, never mind really, but basically we're working within this current build directory for the current dir. We can just access build outputs. This target property thing is sort of what I was talking about. Where then, rather than hard coding paths to just different things, you actually have these more higher level concepts. Boot CMake lists, and so we actually have this higher level concept of a boot image that actually has a path attached to it, and then over in other parts of the build system, we just know, okay, we want the boot image, and then let's just use whatever path it's at, and we don't need to hard code these details. And I think we could technically do the same thing for the kernel image here, I guess, because we attach this path property to it. So just out of, like, it's a little bit verbose, like the syntax is a bit verbose for how you do this, but I'm just curious to try this out. So here we're going to do it's the kernel elf. We're copying the kernel elf, the path of its path, and copying it in here. And let's just see what happens. And so I've modified the CMake lists, and so it should kind of re-trigger copy. Oh no, oh. So that did not seem to work. What's up, Ali? Are you using C++? Kind of. A little bit. I mean, the OS is mostly C, but we did add support for C++, and I do intend to use C++ as the main language for it. Copy, no such file. Okay, that did not work as I expected. So let's just do it the simpler way, which is kind of just putting this path here, and just see if that works. So that worked, and hopefully we get this behavior where it doesn't rebuild again. Okay, and we get it. Nice. I'm just gonna go with that for now. So we make this dir, we copy in the kernel, we copy in the Limine files, we package everything up. We make a symlink just for fun. And then that's like kind of it. So that's sort of like level 1 of this. So I'm gonna add this. One of the reasons to try CMake, yes, the compile commands on JSON. That's true. That's a huge benefit. Yeah. Because then you don't need to use these other external tools to generate that file on top of the make files or whatever. It just does that for you. So that's kind of nice. Okay, so this is level 1, and I think it's kind of what we need. I'm sort of just curious with Like, what if we added a CMake lists.file in here and actually made this a target? I'm just gonna ask AI to do this and see what happens. Yes. Okay. Code base. I'd like to add CMake lists next file to the Limine subdir and make a build target that corresponds to the limine.conf file. It's just static file to be referenced by other build targets. No compilation happening. Then I want to port kern CMake lists to port the kernel ISO target in to depend on this Limine conf target, and ideally use a property to access the actual path. Can you do this? Almost. All right. All right. So it's cooking on something there. Okay. So let's see, what is it doing? So it has it, so it added CMake lists into this folder, and it's a pretty simple one. It just has a variable that points to the config file. Then it created a custom target, which depends on the file, okay? And that's kind of it. And then it sets this path property. It sets a path property on the target. And this is the pattern I'm using in other places to attach like a path to a build target. It's kind of like object-oriented programming with like, you got this object and then you can access its data members. It's exactly the same concept, just in the build system. And so we added this, and then the nice part, and it even read the comment, is that, so now we formally depend on that conf target. And then here, the idea is just to use this path thing. So I'm optimistic about that. Like I think it did a pretty good job with that. So let's just let's run it. And I'm going to do that verbose thing again. I think it works. You know, I'm just going to clean out this and restart. Building, blah, blah, blah. And here it is. So so it worked. It was totally able to find the Limine conf. And if I run the build again, we should see that nothing happens, because none of the inputs have changed. And so nothing happened at all. it didn't run any of these commands again. And then now for the real test, what we do is we can modify this file. And if we modify this file, that's going to activate all of these dependencies in the build system, and it's going to recompile the kernel ISO. And that's the key benefit you get when you express the dependencies like this. You can make this aware that it only needs to recompile if this thing changes. And so I'm just going to add hello world, blah, blah, blah. And I am really going to hope that it's going to regenerate the image. I'm actually not sure it did. Wait, I think it did not. It's a bit easier to tell with verbose mode not being on. I think it did not. I actually think it did not. And that means there's something kind of subtle. I sort of think the reason it says this thing depends on this, but I think I have a guess that this means it depends on the existence of the file, but it's not necessarily tracking changes to it. Maybe that was actually kind of surprising to me. This didn't work. Let me run this one more time. I'm just gonna just to make it more clear. So I'm just gonna do make kernel ISO. I'm just curious what adding some more CPUs does. Okay, so that was the normal first build. Then we get, it should not do anything. So it's very clear that it did not do anything. And then we say hello. And then it seemed like it didn't do anything. It did not do anything. So something went wrong here, and I'm going to ask the AI to fix it. Just to limine.conf. Do not re-trigger. Oh, but it's a 20-second break. All right, be right back. Oh, I didn't give it enough context. Dang. Okay. Okay, this is kind of interesting, a little bit different than what I expected. Oh, what? I slightly don't trust this. Let me. let me ask it. Actually, I'm gonna ask ChatGPT. Give me 1 second. Yeah, I feel like that's a little bit overkill for what we're doing right now. Okay, ChatGPT. I'm gonna ask some similar question. CMake project. I have a static file that needs to be referenced in command lines of a separate custom target. How can I package that static file into a CMake target that the custom target can depend on? And then to the static file re-trigger the build for the custom target. Okay, this is what the first attempt did. Depends on blah 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 blah. Okay, so we have a custom command. This is like some detailed CMake stuff, but like you have the command and the target. And the command just says like I'm a target, or the target says I'm the target and I need this thing, and then the command says how to produce that thing. And then you just say this thing depends on this. Interesting. And that, it seemed like that didn't work, but I sort of don't know how much I really care about this. I don't love this stamp thing. Stamp idea. Surely CMake has a way to directly allow you to depend on files and trigger rebuilds if they change, right? Base add file to chat. File to chat. It just keeps repeating itself. This is kind of an interesting idea. Okay. So yeah, no, that stamp thing is whack. So now we're back to the very simple target that wraps the file. And then instead of depending on the target, it depends on like the actual file, which is like a little bit strange, but should still work. And so I'm just gonna build. So that regenerated it and then now it shouldn't, and then now it shouldn't, and then now I'm going to change this, and then now it should, and then it did it. Okay, so that's working. So now it doesn't, and now I'll change it again, and now it does, and now it doesn't. Perfect. So so that's looking good. I will keep these changes and yeah, I guess I will keep this. I don't know if I want this here though. This sort of seems like it goes I guess alphabetical order. I don't know. Yeah, whatever. So now we're depending on two things here. What do so just to confirm, if we don't have this, it seems like things break. Just to really confirm that. So we rebuild, nothing's happening. Oops. Conf. We change some stuff and things don't recompile. Okay, so that's like actually broken. So we really do need this. What about this line? I think we can kind of get rid of this line actually. So things are things recompiled, and then now we change it again. Things recompiled. Yeah, okay, so that shows that this line is not necessary. And so now the question is, can we instead of doing this, can we do this? So rather than hard coding that path, again, let's just use this path in the Limine conf target. I wonder if that will work. So now it's not doing anything. Change the file, and it's doing something, and then not. Okay, that's looking good. Change it again, recompile, and then it doesn't, and then it doesn't. And so I think we have found our final solution. It's this. Yes. We, for some reason, we, depending directly on Limine conf, does not work. It does not re-trigger build on, oops, build on modification. All right, check this out. I mean, I will go into here and, oops, CMake, Limine, CMake, yeah. Yeah, we don't need this, these comments. All right, let's take a look at our handiwork. So top level, CMake, add the Limine, add this, like, this is like a bit of a hack. I'll add it to do while we're here. To do find a better way. Okay, then we have our Limine folder. We have this file, and then a basic build system thing that wraps it. And then we have our new target, custom target for kernel ISO. And it seems like there's a straight white space here. Kind of a bummer. Okay, so get rid of that white space. It's looking kind of clean. I wish we had syntax highlighting here. I wonder if I need to open the other directory. let me just do that really quickly. All right. I don't know. I find this a little bit more pleasant to look at. So yeah, we have our build rules, and yes, so that's going to be it. That's going to be our commit. Add Limine and build kernel. I mean, technically, we could even separate this into two commits. We could have one commit that adds just the Limine target, which is, so it's just the Limine folder and this one line. I'll just do that, add Limine. And then we have one commit that actually makes use of that for building kernel ISO. Build os.iso with Limine. Okay. Whew, all right. Nice one. So let's just see that run one more time. Build things, and we'll just make J16 kernel ISO. I wonder, how do you specify the default targets in CMake? I actually don't really, I forget, but whatever, that's not something for right now. Build the kernel, and yeah, look at that out. The output looks pretty nice, pretty pleasing output, and we have our os.iso right here, ready to be used with Kimu next week. So that's going to be it. I'm going to end the stream here. We'll do my typical self-promo. Discord, feel free to join the Discord if you like what we're doing here. Subscribe to the channel if you like the topics. And I'll see everyone next week. Have a great week, and we'll continue with powering through some of these CMake, Limine, probably get into some Clang LVM stuff too, and eventually make a custom OS. So cool. Have a nice one.